the structural analysis. Initially, we have taken the basic concepts of elasticity. It will start from the forces acting on the body. There are three types of forces. Body force. It has three components: FBX, FBY, and FBZ. And we are considering magnetic force, gravitational force, and inertia force as a body force. Next type of force is surface force. It has also three components. It is uniformly distributed over the surface, and it is measured in terms of the force per unit area. Px, Py, Pz, these are the three forces. Then point load, it is considered as a nodal load. After that, effects of force is the displacement. We have taken the displacement for one dimensional and two dimensional, and you have to remember this equation: U is equal to nu. Next one, for two dimensional, there are two components of the displacements, u and v, because it is a vector quantity. Okay, now this is the displacement equation or interposition polynomial for the displacement for two dimensional triangular element. Now here also you have to remember this u is equal to n into u, and n for this is n1 0 nj 0 nk 0 and so on. Okay, that we have discussed. Now after displacement we have taken the strain. Now strain for one dimensional is epsilon x directly du by dx. It is only one component, and when we replace u by n into u, you will get this epsilon x equation, and that is the derivative of shape function into nodal displacement, and this we can write in the form of epsilon is equal to b into u. Next is for two dimensional, there are three components of the strains, and same equation we are getting here, that is epsilon is equal to b into u. That also we have discussed. After that, stress. Now relation between stress and strain we have seen here. First, in finite element method, first we are calculating displacement, then from displacement we are calculating the strain, and from strain we are calculating the stresses by using this equation: sigma is equal to d into epsilon. Here sigma is the stress matrix, and depending upon the discipline or type of the problem, your sigma matrix will be changed. That D matrix, it is a constant matrix, it is a material property matrix, this also changed. And epsilon is strain matrix, it is also discipline dependent. Okay, now for two dimensional there are two cases: plane stress and plane strain. Plane stress, stresses in all stresses in one direction are 0. Okay, this also we have covered. Now this is a stress strain relation, or it is also known as generalized Hooke's law for two dimensional plane stress problem. Now this is also written in the form of sigma is equal to d into epsilon. Okay, now plane strain. For plane strain, one strain in all strains in one direction are 0. Now this is a stress strain relation, and this one is your D matrix. Now we can write sigma matrix is equal to d into epsilon matrix, that is stress matrix is equal to material property matrix into epsilon matrix. Here depending upon the type of problem, your D matrix will be changed, sigma matrix will be changed, epsilon matrix will be changed. Okay, now for one dimensional case, D is equal to modulus of elasticity. Okay, because it has only one stress component, it has only one strain component, and modulus of elasticity is the material property for this problem. Okay, after that we have seen the thermal strain. Thermal strain in finite element method, it is considered as a initial strain. Already you know this equation: epsilon 0 is equal to alpha delta t. Okay, and for two dimensional it is alpha delta t 0. It is a thermal strain matrix for plane stress condition. Here, because of the thermal load, we will not get the shear strain, because there is a uniform distribution of temperature in all directions. We will not get the change in angle. Okay, now for plane strain, only 1 plus mu will be added here, and remaining matrix is same. Okay, now here resultant stress, when we consider thermal strain as the initial strain, resultant strain is epsilon is equal to epsilon minus epsilon 0. Epsilon is equal to epsilon minus epsilon 0. This is the total strain, and this is the initial strain. Okay, here you have to remember this equation. This is your total strain, and this is your initial strain, and resultant strain is initial strain when we subtract from the total strain. Okay, now therefore your stress relation will be changed. Stress becomes sigma is equal to d into epsilon minus epsilon 0. Okay, now this we have seen at the time of last lecture. Also we have seen the principle of minimum potential energy. Potential energy is the addition of strain energy plus work potential. Now already we have seen this one, this equation, that is a strain energy plus work done by external loads or work potential. Okay, now it is half of strain energy per unit volume, all of you know, half of stress into strain. After that, total strain energy is integration of this strain energy per unit volume over the volume. Okay, next, this also I have explained why I have taken this transpose, because size of stress and strain matrix is not going to permit the product of matrices. So I have taken the transpose and I have changed the sequence of these two matrices. Okay, already I have explained it. Next one, work done by the forces is, first the force is body force, work done by body force, work done by pressure load, work done by point load. These are the three forces acting on the body, and you will get the work done because of these three forces. Okay, now this is the mathematical relation for work potential under the action of all these type of forces. Here this is the displacement of body, or this is displacement of element in finite element analysis. This is also displacement of body, and this is the displacement of node or point. Okay, now next one, total potential energy is addition of work done and strain energy. Here strain energy and work done are acting in opposite direction. One is because of the internal resistance and one is because of the externally applied load. This is because of externally applied load. Okay, so here these quantities are negative quantities. Okay, now principle of minimum potential energy, this is total potential energy equation. According to principle of minimum potential energy, derivative of this total potential energy with respect to the U matrix is 0, because this I is function of U. Okay, now here I have written this equation, di by du is equal to 0. Okay, this up to this we have covered. Any doubt, if you have any doubt up to here, you can ask me. I will start the formulation. Before that, if you have doubt, you can ask me. Akshay Patil, have you checked it?
Yes, sir.
If you have doubt, you can ask me. Everyone can ask. Okay, I think there is no doubt. Now I will start the formulation of finite element equation for structural problems. Okay, now finite element equation for the structural problem is formulated by using principle of minimum potential energy. Okay, that is principle of minimum potential energy is used to formulate the finite element equation. That means potential energy is minimum when structure attains the equilibrium condition. Means we are considering the equilibrium condition of the structure, and we will apply the principle of minimum potential energy, and from the application of principle of minimum potential energy we will derive the finite element equation for the structural problem. Now for that purpose we will start from the principle of minimum potential energy. Okay, and we will convert that minimum potential energy into our required form. Okay, then we will apply the principle. Okay, now I will start with the potential energy. You see here, all of you know this equation. Potential energy, it is strain energy plus work done by the external load. You know this equation. Now I will take strain energy first. I will give the appropriate form to the strain energy. Then I will go for the work done by external loads. Then I will go for the principle of minimum potential energy. Okay. Now I will take strain energy. Now you know this total strain energy, pi is equal to half of stress into strain over the volume. That is integration of half of stress into strain over the volume. Now in mathematical form, it is pi is equal to half of strain transpose sigma dV. Okay. Now all of you know this equation. If you are doubt, you can ask me in this equation. It is half of strain transpose sigma into dV. Now what I will do, I will consider initial strain also. I will consider the initial strain. Now when we consider the initial strain, here when we use this equation, you will get the strain energy total strain, due to total strain. But resultant strain is total strain minus initial strain. Okay, total strain minus initial strain. So when we want to apply the equation of the strain energy for applied load or for resultant strain, then this strain in this equation will be replaced by epsilon is equal to epsilon minus epsilon 0. Already you have seen this is thermal strain or this may be initial strain. This is your initial strain or this is your thermal strain. Okay. So your resultant strain it is equal to total strain minus epsilon 0. Okay. Now this I will replace by this equation. Okay. Now I will get here phi is equal to half of strain transpose sigma. Strain transpose means this strain I am going to replace by this one. Okay. Now first term is strain transpose and second term is epsilon 0 and multiplying term is sigma. Okay. So this equation is formed in this form. Okay, or it will take this form. Okay. Any doubt in this equation? Equation number 3. Any doubt? I have replaced the epsilon by epsilon minus epsilon 0 just as a resultant strain. Okay. So it becomes, you put this value in this equation. Now you will get epsilon minus here half into epsilon into sigma minus half into epsilon 0 into sigma and integration of whole term over the volume. Any doubt in equation number 3? Have you got it? If you have doubt, you can ask me. Now write this equation or write this content of this slide on your notebook, and till that if you have doubt, you can ask me. Write this content, equation number 1, 2, 3. Okay. Over. Next one. Now same thing I will repeat for this stress. Now if we go for the stress is d into epsilon. Okay, d into epsilon. This equation I have taken equation number 3 as it is. Now I will replace this stress by d matrix, and this d matrix is material property matrix into epsilon. Okay. Now again this epsilon is equal to epsilon minus epsilon 0 Okay. Now so your stress becomes, this is your stress sigma matrix, okay. So this becomes stress is equal to d into epsilon, that is your total strain minus initial strain epsilon 0. Okay. Or you can see here, first I have replaced the strain only, then I am going to replace the stress by d into epsilon minus epsilon 0. Already you have seen this equation. Here epsilon is your total strain, and epsilon 0 is your strain due to thermal load. Okay. Now you can see here how it is going to take the form. Here, from stress strain relation, stress is equal to d into epsilon. I am using general relations, d into epsilon. Now here epsilon will be replaced by epsilon minus epsilon 0. Therefore your stress becomes stress into d into epsilon minus d epsilon 0. Okay. Now you put this term in the equation number 3. Put this term in the equation number 3. Now what is the first term? First term is half of epsilon transpose into this complete term d epsilon minus d epsilon 0. That is, this term will be replaced by, that stress term will be replaced by d epsilon minus d epsilon 0. Okay. Now second term epsilon 0 transpose into you have d epsilon minus d epsilon 0. Okay. Now see here how it will take form. Here putting in equation number 3. Okay. You see here epsilon transpose d epsilon minus d epsilon 0. Here this is the sigma your, okay, and here you have this sigma. Okay. Any doubt in this equation? Here half of epsilon transpose d into epsilon d into epsilon 0. Just I have used this in this equation, equation number 3. Okay. Now after that minus epsilon 0, again I have used the sigma here, is d minus d epsilon 0. Okay. Now I will multiply this term to this bracket, this term to this bracket. Okay. And I will write the separate integration for each term. Now how it will become? Here again this is same term. Now you see this, when we multiply by this term to first term, it is half of epsilon transpose d epsilon dv. This is your first term. Okay. First term. Now second term is epsilon transpose. Second term is this epsilon transpose. Now here I have written separate integration for each term. It is half of epsilon transpose d epsilon 0. Okay. Now next term here this term is over up to here. Okay. Next term half is there, half epsilon 0 transpose d into epsilon. This is your epsilon 0 transpose d into epsilon. Okay. Next half of epsilon 0 transpose d into epsilon 0. Okay. And this minus it will become plus here. Any doubt in this equation? Raise Chogle. If you have doubt, you can ask me. Raise.
Sir, no doubt.
Ajay Mudurkar. Ajay Mudurkar. Have you got it? Why I have taken this form? Okay. Now after that, you know one matrix rule. That matrix rule is, it is A transpose B, that is matrix A transpose B into C equal to C transpose B into A. This is the one rule from the matrix, that is transpose of A into B matrix into C equal to the transpose of C matrix into B matrix into A matrix. Now that this rule will apply to this term and this term. You can see here epsilon transpose d epsilon 0, and here it is epsilon 0 transpose d epsilon. Now when I will I say this as a, this as a, this is a B, this is B, and this is a C matrix. Same thing, here it is C matrix, here it is B matrix as it is, and this is your A matrix. Now when we compare this rule with these equations, these two terms are same terms. That means these two terms are equal terms. These two terms are equal terms. That means half of epsilon transpose d epsilon 0, it is equal to the half of epsilon 0 transpose d epsilon. Am I right? अक्षय शिंदे बरोबर आहे ना?
Yes, sir.
Okay. Now means I can add these two terms, this term and this term I can add. Okay. I have written also I have written here. You can see here epsilon transpose d epsilon 0 is equal to epsilon 0 transpose d epsilon. Okay. It is a one standard rule from the matrix algebra. Okay. Now when we add these two terms, this half and this half, it becomes 1. Okay, it becomes 1, or it becomes epsilon transpose d epsilon 0, integration of epsilon transpose d epsilon 0 over the dv. So your potential energy becomes half of epsilon transpose d epsilon, sorry, not potential energy, it is a strain energy. Strain energy becomes half of epsilon transpose d epsilon dv. This is your first term. Okay. Second term, it is addition of this term and this term. Okay. Addition of this term and this term. Here half will be cancelled and it will be replaced by 1, because half plus half, it is 1. Okay. It becomes epsilon transpose d epsilon 0 over dv, and last term I have taken as it is. Okay. Now this is your equation number 4 for the strain energy. Now what I will do, you know the relation, that is epsilon is equal to, okay, I will take on next slide, same equation I have written here. Now next is epsilon is equal to b into u. Now for in finite element method, epsilon is equal to b into u. Okay. Now this equation also you have seen, that is b is your matrix formed by the proper differentiation of the shape functions. Already I have shown what is a b for one dimensional element, what is b for two dimensional element. Okay. So here b is equal to b is your proper differentiation of shape function, and u is your nodal displacement matrix. For one dimensional element, it is minus 1 upon L, and 1 upon L, it is your B matrix, and U matrix is UI or U1 and U2 or UJ. Okay, this is your B into U. This is your B into U matrix. Okay, B into U matrix. B is your derivative of the shape function matrix. Here, this is the derivative of N1. This is derivative of N2. Okay, and for two dimensional, it is 1 upon 2A, A10, B10, sorry, B10, B20, B30. That is your B matrix is for two dimensional. 1 upon 2A is common here, 2A, and here you have B1 or BI 0, B2 0, B3 0. Next C1, sorry, here it is 0, C1 0, C2 0, C3. Okay, and here it is C1, B1, C2, B2, C3, B3. This is your B matrix for two dimensional element. Okay, two dimensional element. Now what I am going to do, I am going to replace strain, that is epsilon matrix by B into U. Epsilon matrix by B into U. Now when we replace epsilon matrix from this equation by B into U, what is the first term? Can anyone tell what is first term? What you will get as a first term? Rishikesh Kumbar, can you tell me first term? Rishikesh Kumbar?
Sir, it looks quite difficult.
Which one? This one?
No sir, first step.
First means this one. You are
No sir, upcoming step.
next step. Okay. Now you just replace this epsilon transpose by b into u. See here. Here, if can you replace this term epsilon? Epsilon. Here I have written epsilon is equal to b into u. Na? Do you know this b into u is equal
Yes
to
sir,
epsilon?
yes sir.
Yes, b into u is equal to epsilon. Here I will write here. Here epsilon is equal to b into u. Epsilon is equal to b into u. Okay. You know this equation. Am I right? Now I want to replace epsilon from this equation number 4 by b into u. That is all epsilon terms I am going to replace by b into u. Now here here epsilon directly we can replace b into u, but when we go for epsilon transpose here epsilon transpose, how we can replace epsilon transpose by b into u? It is u transpose into b transpose. Okay, see here epsilon is equal to b into u means epsilon transpose equal to transpose u transpose into b, u transpose into b transpose. Okay, into b transpose. You have to remember this. You have seen this in matrix also. Epsilon transpose is equal to u transpose into b transpose. Now can you tell me what is how we can replace this one? Yes, you tell first term. Rishikesh Kumbar.
Yes sir, integration of 1/2 u transpose b transpose
Uh,
into d into b matrix into u into dv.
okay. Any other now? Rishikesh Dore, can you replace this term? Rishikesh Dore.
Yes, sir.
Yes, you tell. Yes, tell me. Saurabh Pawar. Okay, I will tell you.
Yes, sir.
Yes, you tell me how to replace this one. If you are not getting, you can ask me. Why you are keeping mum? Shreyas Chowgule.
Hello.
Yes, you tell me how we can replace second term.
So epsilon not ला काय घ्यायचं ते माहित नाही.
Epsilon naught, it is as it is because there is no relation for epsilon naught. Epsilon naught you keep as it is.
Okay. मग
Okay.
एप्सिलॉन ट्रान्सपोज च्या ऐवजी यू ट्रान्सपोज बी ट्रान्सपोज इंटू
Yes.
डी इंटू एप्सिलॉन.
Okay. Epsilon TP not you have to keep as it is. Epsilon transpose you have to replace by u transpose b transpose because you have this relation. Already you have seen this relation and you have also calculated. And one more thing I want to tell you here, this relation is required for numericals also. Okay. Now I will show you how it will be. Here this first term I am going to replace by epsilon transpose, that is u transpose b transpose, because I will write here epsilon is equal to it is in matrix form, you have to remember, b into u. Okay, and epsilon transpose is equal to u transpose into b transpose. It is not new for you. Here you have studied lot of times, you have solved lot of numericals on this. Okay, because it is one part of the matrix. Now I will get this pi matrix. Here I have written epsilon is equal to b into u. Pi matrix, that is a strain energy. It is 1 half U transpose B transpose, this U. D is as it is. Okay. Next, epsilon is equal to B into U. Okay. Or next, epsilon transpose is equal to U transpose B transpose. D is as it is and epsilon 0 is as it is. Okay. Now, next term is epsilon 0 transpose D epsilon 0. Is there any doubt in this equation? Equation number 5. This is a strain energy equation. If you have doubt, you can ask me. Here, is it necessary to repeat once again this derivation? Mahesh Jalte, have you got it? Mahesh, what you are not responding? If you are getting, you can tell me yes, sir. If you are not getting, you can ask me. I am not getting. Yes. Pranjal Selar,
Yes, sir.
have
Understood,
you
sir.
got it? Okay. Next, Akshay Shinde,
Yes, sir.
have you got it?
Yes, sir.
If you are doubt, you can ask me. Arman Atar. Next, Saira Shinde.
Yes, sir.
Have you got it?
Yes, sir.
Okay. Toramkar, Madhav Toramkar. Here. Next, Pranali Kharat.
Yes, sir.
Can I go for next step? Here, if you got this equation number 5, I will go to the next step. It is very big equation and it is very simple. Here I have not done any biggest derivative or integration. Here it is just a matrix manipulation, just use old terms in the equation. Equation is bigger, but steps are simple. Okay, this is your strain energy. Okay, now after the strain energy, for potential energy, we have to calculate the work potential, work done by external forces. Now, have you written this equation number 5 on your notebook? Akshay Patil, have you written this on your notebook? Akshay Patil,
Yes, sir. Yes, sir. Yes,
have
sir.
you completed up to here?
Yes, yes, sir.
Can I go to the next?
Yes, sir.
Okay. Now work potential. Second part of this potential energy is work potential or work done by external forces. Now work done by body force, work done by pressure load and work done by point load. Okay. Now you see here this equation. This equation already I have explained while writing the principle of minimum potential energy. Here this is the work done by body force, this is the work done by pressure load and this is the work done by point load. Okay. Or now what I will do, I will replace this u by n u by n into u. Okay. Here this is the variable displacement, this is the variable displacement. Okay, and this one is the displacement of node. Okay, nodal displacement, we can say it is nodal displacement because that force is acting on node. Okay, now here this is your variable displacement, this is a shape function matrix and this is your nodal displacement matrix. Now what I will do, I am going to replace the variable displacement by product of shape function matrix and nodal displacement matrix. Shape function matrix by and nodal displacement matrix. Okay, now you put this in this equation, work potential equation. Now Saurabh Pawar, you tell me how we can write this work potential equation. सौरभ पवार तुम्ही सांगायचं आहे, अदरवाइज you tell me that is you have some problem with this derivation. Have you got it, Saurabh Pawar, whether he is present or not?
Yes, sir.
Then you tell me how we can write this work potential equation by using this n into u.
U is replaced by n into u. And
Now you
integration of
okay. Now you tell me first term, this one. Yes.
Wp is equal to
Wp is equal to
integration of n transpose u transpose.
Now here on last slide I have explained this how to write the product, that means when we have to calculate the transpose. Here it is same to the last one. You see this one here, epsilon transpose I have replaced by u transpose b transpose. Here you have u transpose you have to replace by n into u. Now how you can do it? Yes, Pawar.
N transpose u transpose, sir.
You have to change the sequence of this, na? When we want to take the transpose, you have to change the sequence and then you take the product. That is u transpose is equal to u transpose into n transpose. Okay.
Yes.
Or have you got it?
Yes.
Same thing I have done on last slide. Okay. Now so
Yes,
your equation becomes u transpose n transpose into FB is as it is in over volume, okay, or into dV. Next one, in pressure matrix also, here u transpose I have to replace by u transpose into n transpose P, and it is integration over the surface. Why? Because it is a force per unit area over, and next it is not necessary to replace this because it is already nodal displacement. It is not displacement of element or displacement of body. It is nodal displacement. So we cannot write this equation for this ui. It is a displacement of I node only. Okay. So this is again u transpose, that is u transpose into f. Okay. Over. Any doubt in equation number 7? Pandit? Any doubt? Pandit काय doubt आहे का? Here it is simple thing.
No, sir.
Okay. Now this is your work potential. Now see here, you have seen this FB has 3 components, P has 3 components, F has also 3 components, that is FBX, FBY, FBZ, PX, PY, PZ. So I have written, it is not compulsory step, you can write or not necessary to write here, but when we use this for 3-dimensional, you have to write it. Okay. It has 3 components, FBX, FBY, FBZ, PX, PY, PZ. Here this is F. Okay. now after that I will write the potential energy equation. Potential energy equation is addition of strain energy and work potential. Now strain energy is, here I have written total potential energy is strain energy plus work done by external forces. This is your work done by external forces, and already we have derived strain energy equation. This is strain energy, this one and this one. Up to here you have strain energy, that is u transpose b transpose d b u dv, u transpose b transpose d epsilon 0 here we have derived this one, and I have subtracted work potential from the strain energy. Why? Because their signs are different. Have you got it? Their signs are different, therefore, or their directions are opposite. Directions are opposite. That means strain energy is because of internal resistance and work done is because of the externally applied load. Therefore, this is negative, and this term is negative. That means this total term is negative. This total term is negative. Okay. Over. So I have subtracted this work done from the strain energy. Already we have, this is your equation number 5. Strain energy is your equation number 5. That means I have subtracted equation number 8 from the 5 for getting the total potential energy. Okay. Now this is equation number 9. Any doubt in this equation? Here just I have written all the terms as it is. All the terms as it is. That is equation 5 is your strain energy equation, and 8 is your potential energy, work done equation. Okay. These terms I have written as it is. Any doubt up to here? Here, terms in the equation are bigger, but that procedure is simple. Okay. Now this is the potential energy of one element. This is potential energy of one element. Now when you want to calculate the potential energy of structure, for calculation of potential energy of the structure, you have to take the summation over all elements. All elements. So total potential energy is sum of from element number 1 to E. Okay, that is for all elements, sum of this equation. That is, I have written same equation, just I have added the summation symbol here. Sum of all terms. Okay, sum of all terms over next. Now I will apply the principle of minimum potential energy. Before application of the principle of minimum potential energy, I will tell you, that is principle of minimum, according to principle of minimum potential energy, it is di by du. That is, du means it is a matrix. That means they differentiate your potential energy with respect to U matrix and equate with 0. Now here this derivative is not complicated thing. It is same to the your regular mathematics. Di, okay, I will write here di by du equal to 0, because principle of potential energy is minimum when structure is in equilibrium. When structure is in equilibrium, your potential energy is minimum. Here minimization of the minimization principle is di by du is equal to 0, because I is function of u. How I is function of u, I will tell you. Here B matrix for one dimensional, it is minus 1 upon L. Okay, means this B matrix is constant matrix. D matrix is a material property matrix. For one dimensional, it is only modulus of elasticity. It is material property matrix. Again B matrix. Okay. Now here variable is u. Okay. Now your this term B transpose dB, it is constant term. That means product of these three matrices is constant. Again in second, B transpose D epsilon 0, it is constant. Here epsilon 0 D epsilon 0, there is no u term. Okay, this is constant term, and here it is constant term. Okay, this is also constant term. Or now your potential energy is function of I only. Therefore, we have to differentiate with respect to I and equate with the 0. Okay. Now this is known as principle of minimum potential energy. Now when we can anyone tell what is the differentiation of first term? Can anyone tell? Shreyas Chogle, can you tell it? What is derivative of first term? Okay, okay. I will ask one question. Says, what is integration of this? Sorry, what is derivative of this d dx of x? Okay, here it is x d dx of x into constant into x. What is derivative of this? श्रेयस चौगुले काय सांगता येते का? डेरिव्हेटिव्ह ऑफ x इंटू कॉन्स्टंट इंटू x.
सर ते दोन्ही एक्स सेम आहेत की वेगवेगळे आहेत ते दोन?
सेमच
एक्स
सेम
इंटू
सेम.
सी एक्स काय आहे ते, म्हणजे सफिक्स आहे काय एक्स ते?
नाही नाही, x इंटू कॉन्स्टंट इंटू x. इट इज लाईक दिस, दॅट इज कॉन्स्टंट इंटू एक्स स्क्वेअर. म्हणजे तुम्ही कॉन्स्टंट इंटू एक्स स्क्वेअर लिहिता, बरोबर आहे का? बरोबर आहे का? त्याच्याऐवजी मी काय लिहिलं, x इंटू कॉन्स्टंट इंटू एक्स. इट इज सेम टू दिस वन. येस,
2cx येणार ना मग?
2cx. बरोबर आहे, 2cx. Am I right? Do you agree with this? Now you see here, you see this term here. I will clear this line. You see this term here. This is a constant term. This is constant term. This is your C. Now u transpose constant into u. Okay. Already I have told you, u transpose into u. U transpose, if it is a matrix, u transpose into u, if it is in matrix form, that is transpose of u matrix into u matrix. It is your u square. Am I right? Do you agree with this? It is square of the u matrix. Okay. Now just in place of this square, what I have written, u transpose constant into u. Now you tell the derivative of this one. Is it 2 into constant into u? Is it?
Yes sir.
Yes. Okay. ऋषिकेश कुंभार, बरोबर आहे ना? ऋषिकेश कुंभार.
Yes, sir.
Now Akshay Patil, can you get this one?
Yes, sir.
Here it is not complicated thing, it is very simple thing. It is constant. This is middle term is constant, which I have bordered. That is, it is in rectangle. That is b transpose d b. It is constant term. Now it is product of u transpose constant into u. Product of u transpose constant into u means it is the it is u transpose constant u. It is same to the u square into constant, one constant. Because of matrix, its size will be different, but you can consider this as a constant matrix. Okay. If it is not matrix, you can take out of the integration also, out of the derivative also. Okay. Over now it is u square into this constant. Okay. So you will get 2 into constant into u. Constant is b transpose d b. Now what about the second term? What about second term? I will clean this. Akshay Patil, सांगू शकता का second term? What is second derivative of second term? There will be
Constant u, sir.
yes,
Constant u.
u constant.
Constant into u. Constant u.
How it is? You see here.
U transpose t. U transpose constant into u.
अरे सेकंड टर्मची डेरिव्हेटिव्ह सांगायची, इंटिग्रेशन नाही. इथं कसं आहे ते, इंटिग्रेशन ऑफ डेरिव्हेटिव्ह ऑफ 1 x. I will replace this u transpose by x with respect to dx into constant. What is its result? इंटिग्रेशन सोडलं तुम्ही, इंटिग्रेशन सोडलं तर डेरिव्हेटिव्हचं काय होणार आहे? डेरिव्हेटिव्ह ऑफ एक्स सी डीएक्स. श्रेयस काय होणार आहे डेरिव्हेटिव्ह?
Sir, B transpose D E epsilon naught.
Yes, because here derivative of x is 1 na, derivative of x is 1. Do you agree with this? That means constant into x or x into constant, derivative of x into constant, it is constant just. Am I right? Therefore you will get constant here, that is u derivative of u transpose b transpose d epsilon 0 is constant. Now Rishikesh Dore, what about this term? Derivative of this term?
Yes, sir.
Yes, you tell me result.
So constant is here, sir.
Constant ची डेरिव्हेटिव्ह काय असते? dc by dx. What is derivative of the constant?
Zero na, sir.
Its derivative is 0. Yes, its derivative is 0. Okay, its derivative is b transpose dbu. Its derivative is, I will mark one by one. This derivative is, this derivative is b transpose d epsilon 0. Okay, next what about this derivative? Derivative of this term, Akshay Shinde. Derivative of first body force term, it is Akshay Patil. Again this term is constant na, because we are differentiating with respect to u. It is
n transpose
n transpose fbx fby fbz. Okay, or now same thing is here, n transpose px py pz, and here it is only f, that is force. Or have you got it? So here,
Yes, sir.
derivative, you will get these derivatives. You check it. You have written this equation. That is
Yes,
equation
sir.
number 10. Now
Yes, sir.
when we differentiate with respect to u, you will get this equation number 11. You see this one, in from first term 2 will be cancelled, that is half of u transpose into this term was there, but u transpose and 2 coming from the derivative, that are cancelled with each other. Okay, 2 and half, you will get first term, this is, you will get second term, u transpose will be removed from here. Now here u transpose is removed, here u transpose is removed, and here also u transpose is removed, and this I have taken out of the square bracket because it is a single or point load. Okay, any doubt in this equation number 11? अक्षय पाटील काय डाऊट आहे का?
नाही समजलं.
समजलं ना?
हो.
Now next one, this is the what we can say, this is your equation coming from the principle of minimum potential energy when we apply for structure. Okay, now what I will do, I will write this equation by taking summation inside this bracket, and I will use separate terms. Okay, now how I have written this one. See here, what I have done here, I will change the color. Here when we see the integration of this term, here it is integration over the volume, now here when we integrate this term over the volume, then no any term is dependent of the volume. Okay, no any term dependent of the volume. So I can take all the terms out of the volume, or I can take any term out of the volume. So I have taken this u out of the integration. Okay, u out of the integration. Here same equation b transpose db u I have written as integration of b transpose db over dv into u. Why I have kept these terms in the integration? Because here for linear elements this is constant, but this b transpose and b is constant for linear elements. When we go for higher order elements, these terms are not constant. Therefore, I have kept this term inside the volume. Okay, inside the volume. That means inside the integration, not volume. Inside the integration. Okay, and u is not, or it is constant when we integrate over the volume. So I am taking this u over the, or u out of the integration, that is integration b transpose db dv into u, b transpose db dv into u. Now second term I have kept as it is. Okay, now this term, okay, I have combined. Okay, that is negative terms, all negative terms I have taken here, that is b transpose d epsilon 0 dv, n transpose this body force matrix over dv, n transpose pressure load over surface, and f is equal to 0. Can you get this equation number 12? See, here I have not done anything here, just from first term I have taken u term out of the integration. Any doubt in this equation number 12? चौगले काय डाउट आहे का?
No, sir, no doubt.
Okay, now what I will do, I will compare this equation with k into u minus f or equal to f, we can say minus f or equal to f, equal to 0, or you can write k into u is equal to f, because these terms you see here, these terms are negative terms. You can take on right side of the equation. Okay, these terms k into u is equal to f or k into u minus f. This is your finite element equation, standard finite element equation. Am I right? Now you compare this equation number 12, with the finite element equation, and you tell me what is k and what is f, what is k and what is f. What is k here? What is k here? Akshay Patil, you see here.
हा
Yes,
सर ते
yes.
मायनस मध्ये आहे ते म्हणजे कसं समजेल?
मायनस इथं काय?
हा ते साईन आहेत ना मध्ये मायनस, त्यामुळे ते काही
बरोबर आहे.
कन्फ्युजन झालं.
You listen here, you see this. When we compare this equation with this k into u is minus f is equal to 0. Okay. Now you see here, u is multiplying factor to this k matrix. Am I right? Okay. Now here you have only multiplying factor for this. U is multiplying factor to this only. Am I right? You agree with this? That means
हा
this is your
yes.
k. This is your k. Or now remaining terms, f, here all other remaining terms, addition of all other remaining terms is your f. This is your f. Okay. Can you get it?
सर
see
ते
here.
लास्टला एफ आहे ते सेपरेट नाही काय ना?
नाही तो सेपरेट येणार नाही. See here, this is your thermal load. Okay, this is your body load, this is your pressure load, and this one is your point load. Addition of thermal load, body load, pressure load, and point load is your resultant force matrix. Okay, this is your resultant force matrix. Are you getting this? हा एफ आहे तो पॉइंट लोड आहे, पॉइंट लोड हा पॉइंट लोड मॅट्रिक्स आहे, आणि हा प्रेशर लोड मॅट्रिक्स. दिस इज युअर बॉडी लोड मॅट्रिक्स. and this is your thermal load matrix, and addition of all these forces is equal to the total load acting on the body. Am I right? समजलं अक्षय? अक्षय
समज
अक्षय
हो
पाटील
सर कळालं आता काय हा
कळालं
कळालं
काय?
सर येस येस सर
Yes, yes. So when we compare this equation with the finite element equation, here you will get here this one. You will get global stiffness matrix K is equal to summation of B transpose dB dV. That is this term from here to here. Okay, we agree with this. Now force matrix. Okay, then I will go for force matrix. Now this is summation for all elements, and when we want to write the elemental stiffness matrix, it is just the summation term will be removed. That is, as global stiffness matrix is assembled stiffness matrix, and for single element, your stiffness matrix is B transpose dB dV. Okay, that I will explain. Here your force matrix. This is your force matrix. You can see here. 4. And this is also what we can say, this is the assembled force matrix. म्हणजे तुम्ही फर्स्ट युनिट मध्ये असेंबली केली का? हॅव डन इट? असेंबली केली ना, तो मॅट्रिक्स हा आला. म्हणजे सगळ्या एलिमेंटचे फोर्सेस ज्या वेळा तुम्ही असेंबल्ड फायनल फोर्स मॅट्रिक्स लिहितात, दॅट इज दिस मॅट्रिक्स. नाउ इफ यू वांट टू राइट फॉर सिंगल एलिमेंट, here summation sign will be removed. Okay, this is a single element force matrix, and here it is single element stiffness matrix. Okay, single element stiffness matrix. This is your single element force matrix. Here your elemental force matrix. Okay, and here it is addition of thermal load plus body load plus surface load and nodal load. Okay, so finite element equation is this one. Finite element equation for structural problem is this one. Okay, this one is your stiffness matrix. This one is your stiffness matrix K. Okay, and this is your displacement matrix U, and on right side total matrix is force matrix. Okay, this is a global, or what we can say, this is a finite element equation. If we want to write for element, this summation sign will be removed. Okay, this summation sign will be removed. This one, and this one. Okay, have you got it? Any doubt here in this finite element formula? So here you read this up to Wednesday. I will upload the notes also. You read this. If you have doubt, we will discuss it. Okay, and I will share the video also, video link. You see the or watch the video. Okay, and if you have doubt, you can tell me on Wednesday. I will explain all the things. So here it is very simple. Just the number of terms in the equations are bigger, so it becomes complicated. Okay, we stop here. I have already uploaded PPT. I will upload lecture notes also. Today or tomorrow I will upload lecture notes, and I will upload the video. सायरा शिंदे बघायचा बरं का व्हिडिओ कंपल्सरी. सायरा शिंदे,
हो 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 सर.
अक्षय शिंदे,
Yes, sir.